This is the third video of chapter 2. This is all on nomenclature, which is how to name compounds. So to know how to name a compound, we first have to know what type of compound it is. So the three types are ionic compound, molecular compound, or acid. The way you will know if you're an ionic compound is that you will be made up of a metal and a nonmetal. You could be polyatomic ions too, but the key is to look at the first part of a compound. If the first element in a compound is a metal, then you are automatically an ionic compound. If you are two nonmetals, just two nonmetals, then that's going to be a molecular compound. And then the third option is if you start with an H, you're an acid. So the key is to look at this first atom. If it's a metal, you're ionic. If it's a nonmetal, you're molecular. And if it's a hydrogen, then you're an acid. So let's focus on ionic compounds first. So you're typically a metal and a nonmetal, but you could be a polyatomic ion too in there. So let's talk first how to name a main group metal ionic compound. What it means to be a main group metal is that you are either group 1, 2, or 3, meaning you always have a +1 charge, you always have a +2 charge, or you always have a +3 charge, like aluminum and gallium. So if you have calcium CaS here, the first question is, what does it start with? It starts with a metal, which means I'm an ionic compound. Then you ask yourself, what kind of metal? And it is a main group metal because calcium is always a +2 charge. And so to name these, what you do is name the first element, which is calcium, and then name the second element and change the ending to "ide." So calcium sulfide. Here, if you see Na3N, you start with a metal, so you're ionic. It's a main group metal because it's always +1 charge. So you name it simply sodium nitride. You don't worry about the subscript there. Remember, you got the subscript by flip-flopping, but you don't have to name or indicate that subscript. BAF2, you start with a, excuse me, a main group metal, barium. He's always +2. So you say barium, the whole name, and then fluoride, and change the ending to "ide." Okay? If you're doing the opposite and you're given a name, so say you're given lithium sulfide, I can still apply the same rule. Lithium is a metal, so I know I'm ionic, which means I'm working with charges. So if it's lithium sulfide, I go to the periodic table and I see that lithium is in group 1, so he is a +1 charge. Sulfide means it's sulfur, and he is in group 6, so he's always -2. And then flip-flop the charges, simplify if necessary, and I get to the compound. Aluminum chloride, very similar. Aluminum is a main group metal. He's always +3. Chlorine is always -1. Flip-flop, and you get AlCl3. Magnesium hydride. Remember, we talked about hydrogen briefly. He can either be a +1. That will be if he's at the beginning of a molecule, or he can be at the end. If he is over here, that means that he is with something positive. And remember, if he's with something positive, that means he must be negative. And hydrogen can either be +1 or -1. So magnesium here is a +2. Hydride is a -1. We flip-flop and we get MgH2. Okay, then if we have a transition metal, the difference now is that our metal has different options for charges. So they can be a little bit trickier because if you have FeO, I could tell the person iron oxide, but the problem with iron is he can be +2 or he can be +3. So you have to indicate using a Roman numeral what the charge of the transition metal is. So this is only if you have a transition metal. So FeO, we would have to go through the process that we saw in the last video, where O is -2, which means Fe must be +2 here. So we would say iron 2 oxide. So the Roman numeral indicates the charge of iron. Similarly, Cu2O, you have a transition metal copper. So you figure out his charge. Oxygen is always -2. Therefore, we need a +2. And so each individual copper is a +1. So copper 1 oxide. Notice the Roman numeral does not necessarily match the subscript because it's telling the charge of copper, not the number of coppers. With these two, I didn't write this in here, but I'll add it to my notes. Iron and copper are really common transition metals, and they have some common names. So iron 2 can be replaced by the word ferrous, and iron 3 can be replaced by the word ferric. Copper is very similar. If it's copper 1, you can say cuprous. If it's copper 2, you can say cupric. And that will come up in some other examples, but I'll add that to the notes. And then SnF4. Sn is the transition metal 10. So you use F as a -1 times 4, that gives you a -4, which means Sn must be a +4 here. So you get 10, 4 fluoride. Okay, if you're doing the opposite, manganese 4 oxide, you know that manganese is Mn. The 4 tells you that Mn is a +4 charge. Oxygen we know is always a -2. So we would flip-flop the charges and we would get Mn2O4 at first, and then we would simplify to MnO2. Similarly, nickel 3 sulfide, nickel has a +3 charge, sulfur has a -2 charge. We flip-flop and we get Ni2S3. Then if you scoot up here to the top, I showed how to deal with polyatomic ions. They're going to be very similar. The only thing is that you just don't change their name. So for example, if you have Na2CO3, you still ask yourself, is sodium a main group or a transition metal? Well, it's a main group because it's always +1. Therefore, I don't need Roman numerals. So I just write sodium. And then I noticed that CO3 is a polyatomic. His name is carbonate, so I leave his name just as it is and say sodium carbonate. And then FeSO4, so iron is a transition metal, therefore you've got to come up with his charge and indicate it using a Roman numeral. So what we have to do is SO4 is sulfate. He has a charge of -2, and if he is -2, then iron must be +2 here. So that is iron 2 sulfate. That indicates that iron is a +2 here. Okay, so you will look and see whether the metal needs a Roman numeral or not, and then you'll use the polyatomic's full name. You do not change the ending to "ide." The other one that is an option is if it starts with NH4. So you would start with the name ammonium if it started with NH4. One more example here is ZnMnO42. Zinc was one of those transition metals that had a set charge, silver, zinc, and cadmium. So there's two options here. We actually need to know that zinc is always +2. So you can write plain zinc permanganate, or you can include zinc 2 permanganate. If it's a transition metal, you're allowed to use the Roman numeral. So that would be fine there. Okay, for binary compounds, which I generally call molecular compounds, the way that you're going to know that you're one of these is that you're starting with a non-metal. So it's two non-metals put together. You can see a few examples listed right down here. SO2, PCl5, N2O3. Remember the non-metals are on the right side of the periodic table? So it's just two of these atoms put together in some ratio. These work very differently because they do not have any charges involved. There's no flip-flopping, there's no simplifying. You just take them as they are and you use prefixes. This is the only time you use prefixes. Sometimes people will want to start using these prefixes for ionic. We only use these if we have two nonmetals. So you'll see the prefixes here. We either need to have them memorized or be able to get to them very quickly. And what you do is just use the prefix that indicates the number of each atom. The only additional rule is that you don't use the prefix mono with the first element. So let's look at some examples. SO2, we see that it's two nonmetals. Sulfur, there's only one of them. So it would be monosulfur, but it won't because it's the first element. So I write plain old sulfur. And then oxygen, there's two of them. So the prefix for two is di. and we say dioxide. So we do end up changing the ending to "ide" again, just like in the ionic compounds. PCl5. Phosphorus comes first. You use the full name. He does not get a prefix because it would be mono, which we don't use on the first element. And then there's 5 chlorines, so we say pentachloride. So I used the correct prefix, and I changed the ending to "ide." Thirdly, N2O3, there's 2 nitrogens, so we say the prefix for 2 is di. So dinitrogen, use his full name. There are 3 oxygens, so it's trioxide. And then the reverse, if we were given silicon tetrabromide, it's 2 nonmetals again. So we would take silicon, there must only be 1 of them because he does not have a prefix. And then tetrabromide means that there are 4 bromines. Disulfur dichloride, there's a di and a di, which means they both have 2. So S2Cl2, and remember we do not simplify when it's a molecular compound.